Hey guys, welcome to your second video in the unit circle series. The second video for this is basically what we're going to do is we want to try to establish ordered pairs for each of these values. All right, for each of these angle rotations, if I were to take from the origin and I want to take an angle that's in standard form and I want to rotate that, for example, 30 degrees. All right. We can get ordered pairs for each one of these points, and we have to use a couple of key pieces of information to do that. All right. Now, some things that we're going to be using is the idea that in the Pythagorean theorem, we know that a squared plus b squared is equal to c squared. Now, in our case, if I were to try to make a right triangle out of this 30-degree rotation, I would be able to make that right triangle like so. Now if you notice, when you started this video, I'd already taken the time to fill in the various degree and radian measures that we talked about in the last video. So before you get started with this, it's probably not a bad idea to go back through that and make sure that you can do all of those angles in both degrees and radians all the way around that unit circle. All right, if you can do that, then we can start talking about finding a value for that specific point. All right, now to find this point, we would go to the right, whatever this distance is right here, and we would go up, whatever this distance is right here. Now, I'm going to teach you this with a pattern, and I want you guys to be able to remember a pattern, and then later on we'll spend a little bit more time using the idea of the Pythagorean theorem. We'll also use some properties of special right triangles like 30, 60, 90 and 45, 45, 90 triangles that we talked about back in section 13.1. All right? But one of the things that you guys have got to be aware of is when I start plugging in these points, we are going to start with, and I'm going to have to zoom this in so you guys can see it a little bit better. If I start with a 30-degree rotation and I work my way around the circle, I want you guys to just take and I want you to try to remember a pattern. All right, try to remember a pattern. So I'm going to get rid of this real quick, and I want you to think about this pattern. I want you to think about, it's a pretty easy pattern here. I want you to think about 3, and I want you to think about 2, and I want you to think about 1. And then I want you to take the other way and go 3, 2, 1. Now, with those numbers, I want to write them each as the square root over 2, and the square root over 2, and the square root over 2, and the square root over 2. Now, the square root of 1 is just 1, so I really don't need the square root there. All right? And then I can identify this ordered pair as the point, square root of 3 over 2, and 1/2. All right? Now, one of the things that we're going to be using as we start to take a look at this unit circle is the idea that each of these ordered pairs can be given as the cosine of some angle theta and then the sine of some angle theta. So right now, if I asked you what is the cosine of a 60-degree angle, well, you should be able to go to your unit circle and say, well, the 60-degree angle results in this point right here, because that's 60 degrees. And at the end of that radius, we can see the point that's 1/2 and then the square root of 3 over 2. Well, the cosine of 60 degrees then should be equal to the x value in this ordered pair, which is equal to 1/2. All right? If I asked you for the cosine of a pi over 6 radian angle, the cosine of pi over 6, well, that would be the x value associated with pi over 6. And if you look at pi over 6, the x value in this case happens to be radical 3 over 2. So we're going to be able to use this unit circle to identify some various points, and specifically to be able to identify exact trig values for a number of these different angles. So if I wanted to take this same triangle that I've kind of drawn in blue over here on the right, and I want to take that triangle and I want to kind of reflect that over into the second quadrant. Okay, you can see that this is also 30 degrees, and so this distance here that I'm kind of highlighting in red along the bottom of this triangle on the left, the red triangle, okay, that distance is going to be the exact same as this distance that I'm underlining in red right now. So these two distances will be the exact same. However, I went to the right, whatever this distance is, and I went up. For this one, I go to the left, whatever that distance is, and I also go up. Now, I want to mirror this distance that I went to the right. Well, as you can see, I went to the right, the square root of 3 over 2. So instead of saying I went to the right as an ordered pair, radical 3 over 2, I went to the left, radical 3 over 2. And so if I wanted to use that then, this becomes to the left, radical 3 over 2. Now, in the diagram on the left-hand side, I went up a half. As you can see here, I went up a half. So if I go over here to the left, I'm going to go to the left, radical 3 over 2, and I'm also going to be going up 1/2. In looking at the 45-degree increments, again, we can see over here on the left-hand side, if I look at a 45-degree angle, and I'll pick a different color here, so maybe it'll make a little bit more sense for you. If I take this 45-degree angle right here, whoops, let's wipe that back out of there. If I take my 45-degree angle, which exists right here, and I say I went to the right, radical 2 over 2, and I went up, radical 2 over 2, well, if I mirror that exact same triangle on the left-hand side over here, I went left, radical 2 over 2, but I went up, whoops, up, radical 2 over 2. And then again, to get to this point, that's going to mirror exactly this point over here. But instead of going to the right a half and up radical 3 over 2, now I go to the left a half and up radical 3 over 2. And so therefore this becomes negative 1/2 and radical 3 over 2. Notice that the cosines in the second quadrant, this is the second quadrant, notice the cosines, or the x values in each of these, is negative, and negative, and negative. And I ask, well, why is that? Well, it's because for every one of these points, I had to go to the left, and the y values, or as we know from before, each of these ordered pairs is cosine sine, right? So the first number for all of these, okay, the first number for all of these is the cosine. Well, that's my x value. All right, and the second value for all of these is my y, or my sine value. All right, so again, all of the signs in the second quadrant are positive because I went up to attain each one of them. Now, continuing to reflect, we can go ahead and we can take a look at the third quadrant. In the third quadrant, for all of these points, I go left and down. So this would be to the left, radical 3 over 2, and down 1/2. Again, I went further to the left, and it should stand to reason that if I went further to the left and down, then we would have the larger number, negative radical 3 over 2, as the horizontal distance, and I went down 1/2. All right? For the next 45-degree increment, I went left, radical 2 over 2, and I went down radical 2 over 2. To get to this 240-degree rotation, I went left 1/2. Whoops, just kind of twisting my paper a little bit there, sorry. I went left a half, and I went down radical 3 over 2. Okay, so what I want to do then is zoom out of this. There we go. For some reason my screen keeps turning black. I don't know if that's going to show up in your video or not. Boy, I sure hope it doesn't, but we'll try anyway. Okay, let's go ahead and take a look at this 300-degree rotation. Okay, for the 300-degree rotation, I go to the right a half and down radical 3 over 2. All right, and so for that reason, then, boy, I don't know, this might be a little quirky here, guys. We're going to the right a half, and we're going down radical 3 over 2. For this 315 degree angle, I go right radical 2 over 2, and I go down radical 2 over 2. And to get to this point, I go right radical 3 over 2, and I go down 1/2. Now I know my ordered pairs don't fit very well. For some reason when I'm zooming it keeps screwing me up a little bit here, but hopefully you get the idea. Now you'll notice in the third